So before we try the problem you sent me, there's a couple of things that we have to recall. First of all, remember I believe it's called the exterior angle theorem, where if you have a triangle where one side is extended, then if you have angle A and B and C out here, it holds true that the measure of angle A plus the measure of angle B equals the measure of angle C. Let's try this again with a different orientation. Let's say that I had something like, let's say the orientation was like this. Let's say I had like this, like that, and let's say that this one came down here. So that's a triangle. Let's call this angle P, Q, and let's put an R there. So it turns out that the measure of angle P plus the measure of angle Q equals the measure of angle R. So these ones here, the sum of their measures is equal to the measure of this angle. This is called is it the exterior angle theorem or the remote? I forget what it's called, but it's true. That's the point. This is a true, this is a theorem from math. There is another thing I wanted to throw at you, and that's this here. If I have, let's say a pair of lines that are parallel, and if I draw a transversal, then here we have congruent angles between here and there. These are congruent angles. They're called corresponding angles. And if I sort of drew another transversal like that, then this here, those are corresponding. So let's keep this in mind and let's try the problem that you sent me, and I will model it for us. It looks something like this. It goes something like that, and this one comes down, and this one comes up, and then it shoots down. Let's just pretend that's what it looks like. This is C, D, E, A, P, B. So what's given to us? We're given that this is parallel to that. And I think that's all we're given, but that's all we need. So watch how we go through this. So let me use black here. So because we have parallel lines, this line segment is a transversal. So for sure, we have congruent angles there and there. I don't know if we'll need that, but it's true, right? These lines are parallel. This is a transversal. Corresponding angles are congruent. Also, for this same pair of parallel lines, this is also a transversal, which means if I put a double here, that's congruent to that there. But they're asking, the question is, can the measure of angle CAD be equal to the measure of angle CBE? They forgot to put M for measure, but it's okay. So CAD is CAD. So they're referring to this angle in pink. Can that be, the measure of that, can it be equal to the measure of CBE? CBE. So let me go like this. And I'm going to put question marks. That's the goal. Can these pinks be congruent? Well, we know that the double blacks are congruent. So the question is, are the pinks congruent? And watch what I propose here. I propose that the answer is no. And let me convince you why. Let me draw something like this. Watch what I do. Let me draw this like this, and I'll prove it to you. So let's call this C, A, and this would be P here, and this is just like that. So watch what I do. Can we agree that if I put, let's just call this single dot, double dot, triple dot. Can we agree that dot plus double dot would equal triple dot, right? Can we agree on that based on what we discussed? Based on what we discussed just a moment ago here, the exterior angle theorem, how if you add these two, it gives you that. So here, if I add this one with that one, I get that one. So what that's saying here in our main problem is that if I add this with that, I get this one. Because these two are added together to obtain this, that means that this individually is not as big as that. That means that this individually is not as big as that. So this is not the same as that. But we already know that this one is the same as that one. So this can never be this. this is always that. So that means that this one can never be that one. Ever, ever, ever. So can this equality hold true? No. How you explain it to them? Well, you're going to have to for sure explain this to them. And maybe you can also throw in the idea of parallel lines with the transversal.